We'll get started. We've got a good number of people joining us, and hopefully everybody will find their way over here to our Zoom meeting. Just our apologies again that we couldn't get our Facebook live stream working, but we're happy to have you joining us in Zoom today for our class for juniors. And just so you know who I am and who you'll be learning from today, my name is Drew Bush, and I'm the Director of Programs at the Fairbanks Museum and Planetarium. And in a moment, I'll introduce you to our excellent astronomy educator, Hannah Buckner. We're really excited, of course, to be partnering with the Girl Scouts of the Green and White Mountains to bring you these classes to help you work on your badges. And just a few notes for Zoom. In our class today, if you want to ask questions, you'll notice if you move your cursor a little bit to the bottom of your screen, there's a Q&A button down there at the bottom. And that's a great place to ask Hannah or myself questions today. You can ask them anonymously if you might want. And we'll do our best to answer them live in class, or we'll do type an answer in there as well. So make sure you check back to see if there's any written answers. The other place you can, of course, chat with us is with the chat button. And you would probably have seen that I've already welcomed folks to our class today. So feel free to chat with us in there as well for today's first class. This is the first of 4 classes for juniors to help you earn your badge. And I'll let Hannah say a little bit more about what that badge is. So why don't you take it away, Hannah?
Thank you. Welcome everybody, and I'm so happy to be here. As someone who used to be in the Girl Scouts, I unfortunately didn't get to finish my tenure as one, but I was very happy to do it. I am so overjoyed to be able to help you lovely ladies work towards your Space Science Investigator Badge as juniors. This is so exciting. I am thrilled to help you along your way to learn more about astronomy and what kind of lies in our universe, and learning more about how you can be scientists in this field. And so I am very excited to talk about this. Just to talk about what we're going to be doing today. Just a brief overview is that we're going to be at the end of this, you should be able to describe that our solar system is made up of planets, moons, asteroids, comets, and dust that orbit the sun. And eventually you'll be able to use a model to describe how our system is spread out. You can find the objectives of this class in a PDF file that should have been uploaded to the Facebook page. So at the end of this, you will be able to know the names of the planets in order, be able to describe the various asteroid and comet locations, and be able to use a scale model accurately. So we'll also talk about what a scale model is towards the end of this. So I've also provided the materials that you'll need for the activity that will be after this class. It's just a little bit of homework. You can, using the materials, you will be able to make your own pocket solar system to be able to learn the scale of the universe and just kind of like the order of everything. There's also a link to the website that we'll be using today to explore our solar system. And let's get started. I posted in the chat if we'll have time for questions at the end. If I don't have time to answer all the questions, or you find you have more questions afterwards, please feel free to email me at hbuckner@fairbanks.museum.org, and I'd be happy to answer them. And I'd be very happy if you called me Miss Hannah. Don't feel the need to call me Miss Buckner or something, or I'd be happy to respond to your questions. So on that note, let's get started. So our solar system, as you may already know, is made up of our sun, 8 planets, 5-ish dwarf planets, comets, asteroids, and ice and dust. And our solar system is quite vast. It is it's vast. I really, it blows about how big our solar system is. and how much is actually in it. As I was saying in the previous class, we typically think of our solar system as just the sun and the planets, but it's really just more than that. Our solar system is containing many, many, many different celestial bodies or objects that exist in space. And so now I will be able to share this with you. If I can pull it up. There we go. So you should be seeing now, unless I messed it up somehow, a scale model of, well, not scale model, but a model and simulation of our solar system. So as you see, our solar system consists of the moon, the sun. I was thinking that this was the moon. We have the sun, we have 4 planets, Mercury, Venus, Earth, Mars. We have the asteroid belt, which is home to majority of the asteroids. We have Ceres, which is a dwarf planet. As we continue to go out, we see Jupiter and Saturn. Uranus is over there. Neptune is the last planet. And we see Pluto is here. We see Eris is over here. And then the two other dwarf planets are Haumea and Makemake. And then if we were to go out even further, we can see that there is another string of asteroids and sometimes comets. And then if we were to go further out, you can't really see it here, but starting around about at 100 astronomical units or AUs, which is about 93 million miles times 100. This is where the start of the Oort cloud would be. So it is in a big sphere around the solar system. And so like a sphere, it's a ball. Everything else is flat except, you know, the Oort cloud is a sphere, and that is because we have a scientific guess or an hypothesis that when the solar system was forming and the sun was being created, so everything was kind of forming within this big ball of gas and dust and rock. It was forming, and the sun was collecting things, and so the Oort cloud is kind of just the remainder of the formation. It's kind of like a graveyard, but it was never living. So it's just the remains of what wasn't used in the solar system and isn't in the belts that we see. So like the Kuiper belt and the asteroid belt. So I think what we'll be doing today is kind of just reviewing the planets in case it's been a while or you haven't actually learned the names yet, but it's fun. So starting off with the sun is a star. It is formed by collapsing gas and dust that is in a star-forming nebula, which means there's gases that are perfect for forming new infant stars, and those become protostars. And those start to burn gas, and they can form solar systems, so like our star. Next to our sun is Mercury. It is the closest orbiting star. It has a slightly oval-shaped orbit, which means it has a path around the sun and is stuck in a path around the sun. And, sorry, I need to take a drink. Mercury is a very small, very rocky planet. And it has a core composed of iron, probably. It probably has a core that is similar to the Earth's core, which has nickel, iron, and something else. And like Earth, it's a rocky planet. Its one side is always facing the sun because it is tidally locked, which means always facing the sun. It's very hot. It's always tanned. You wouldn't want to live here. It'd be very, very painful because it's so close to the sun. Now, if we exit out, learning how to do this, you guys are learning with me. Next, the next star, the next planet in our sun's solar system is Venus. Now, Venus is a lot like Earth. We have a theory, well, not a theory, we have an hypothesis that Venus used to be just like us. Well, not us, but it used to be just like our planet. And something happened where greenhouse gases ran away, not literally, but greenhouse gases are gases that collect heat and trap it and make it warmer. And we had this problem for a while, and we still have it. So essentially, we can't see the core of Venus. We can't see the surface because there's so much dense gas that no light can get through it. And so if you were to be on Venus, well, light can get through it, but it'd be very foggy. It's very gassy because it's got a lot of different smelly gases. If you were to go to the surface, Venus would crush you into a pancake. Wouldn't be fun. But if you were somehow able to float in the clouds between some levels, you actually could live there. It'd be kind of nice. Just like living in Star Wars. I don't remember what planet it is, though, that you can do that. I should look that up. Star Wars is good. And then from Venus, we go to our lovely home, Earth. And funny enough, ooh, you can see where all of these different cities are. Earth is the first planet that is closest to the sun, third rock from the sun. And we are the only planet that is this close that has a moon. I would hope there's not another planet at our level, because then we'd crash with them. That would not be good. So yes, we have one moon. We have an atmosphere that allows us to breathe, and we get our heat from the sun, which gives us warmth and gives our plant life food and allows us to live. And if we go a little bit farther, if I can find it, there it is. There's Mars, and Mars is very, very, very similar to us. Mars could have been an Earth. It's the same size. We know that there's evidence for water having been on here. I mean, we see it at the North Pole and the South Pole. But something happened that eradicated or destroyed the atmosphere, and so it lost its ability to hold heat, and so it can be very warm on one side. Well, warm for us. It'd be comfortable about 81 degrees Fahrenheit at its warmest. But when it becomes nighttime, or if you're on the other side, it can be very cold, about negative 200 degrees Fahrenheit. So it's very cold. But like us, it has two moons, Phobos and Deimos. Those are actually asteroids, if you want to quickly see that. Very cool, very small, love it. And then just beyond Mars, I don't know why it does this, but just beyond Mars, between Mars and Jupiter and where Ceres is the asteroid belt, as we were seeing before. So the asteroid belt is home to the asteroids, the name asteroid belt. And it's also home to Ceres. Ceres is a dwarf planet that is slightly bigger than Mercury, but because it's living in the asteroid belt and isn't really necessarily the size of other planets. It has this classification as a dwarf planet, which doesn't mean it's not as great or special. It actually means it's even more special because it's not as cool as the rest of the planets. It's actually quite not as common. And then beyond Ceres, well, if you want to see Ceres, the dwarf planet, is quite circular, I believe. Yes, hello. It's got some craters. Very cool. Ooh, that looks like an ocean. Very nice. I won't get distracted. I get so easily distracted. Okay. Just beyond Mars is the 5th planet, Jupiter. So we saw that Mercury, Venus, Earth, and Mars are all terrestrial planets, or they're rocky. They have land that you can walk on, technically. Jupiter is the first moon, not first moon, Jupiter is the first planet that is a gas giant. So they do have a surface, a core at the center, but it's not very big, and the majority of this planet is an atmosphere. So it's composed of gases and storms. Actually, with this planet, you'll see all these different lines, and it looks really pretty, but in reality, these are all storms. These are all hurricanes, very, very powerful hurricanes. All these little dots are hurricanes. This is the Great Red Spot. It is one of the most prominent parts of Jupiter, and this is a great big storm. It's about the size of Earth, I believe, and it's been raging on for about 400 years. That's as long as we've recognized it. We don't know if it was before that or how long it'll go on, but it's been there for a very long time. Each of these other ones are pretty small, but they're all very powerful storms. I think it's cool that there's all these different storms that look so similar in the same ring. Jupiter has 79 moons, which is a lot, but it's actually not the most in our solar system. Actually, Saturn has the most stars. I mean, it's stars, moons. Jupiter, this beautiful ringed yellow planet, is quite famous. If you ask a lot of people, they will say that Saturn is their favorite planet, which is no surprise. It is very beautiful, very majestic, very big. It's so big, but it actually has 82 stars. I keep saying stars. I am so sorry. 82 planets, moons. I'm slowly getting there. And Saturn, yeah, Saturn has so many moons, and quite pretty. And you'll actually be interested to know that a lot of these rings, this segment here, where there's like a big separation, let me see if I can pull it up so you don't have the black. Okay, so this separation here, and then this one on the outer end, those are actually formed by really, really small moons. They're no bigger than a small asteroid, but they're still considered moons, but they're not typically that popular, famous, but that's actually how rings are made. You know, you have ice and dust that form on the outside, this is made up of it. And then you have big chunks that just cut through, because the movement of the dust and ice around the planet always stays in the same distance. So if something is cutting through, kind of like if you stick your finger in water and the water kind of falls around it and not just like on your finger, it's doing the same thing, which is pretty cool. And then as we go out from Saturn, we reach the outer regions of our solar system. Just have to find Uranus. So this is the 7th planet, is also a gas giant like Jupiter and Saturn. Cool thing about Uranus is that it actually is rotating on its side, and orbiting the sun, with this one region always facing the sun, just because it's not rotating like the rest of the planets where it spins, where you can always face the sun. It has 27 moons, I believe, if I am correct. And all of its moons are actually named after Shakespeare characters. So if you like Shakespeare, you'll recognize Puck, Miranda, Tatiana, Oberon. Very cool. And to me, it kind of reminds me of a pearl, which I like. And then if you go out a little bit more, you'll reach the last planet, which is Neptune. And Neptune is this gorgeous blue, and it doesn't orbit on its side, but it also has some slight rings, and it has 14 moons. And so, well, you can't see them all, which stinks because they're all really cool. We can learn a lot from their moons. And yeah, so our solar system, you know, we mainly see these planets, but that's not it. So as I go closer, you'll see that all the planets we just looked at have these blue lines. So what then are these orange brown ones? Well, these are the dwarf planets that I was talking about before. These are very small, typically some asteroid-sized planets, or they are very, very small planets like Mercury. This is Eris. Looks very similar to Ceres, as we were looking at before in the asteroid belt. Eris is, I believe, existing in the Kuiper belt, which is another location of asteroids, and also contains some comets. But typically you'll find comets in the Oort belt, or the Oort cloud, sorry, which if you go out to this distance is where it forms, well, from the sun, not the sun. Just around Eris is when it starts to form. And then we also have Pluto. As you'll see, Pluto is very small. It's very, very, very small, which is why it was demoted from a regular planet to a dwarf planet, which is not a bad thing, as I said before. And then we have Haumea. Yes.
So one person, Nicole, is asking, what's the oldest planet in our solar system?
So there's not actually an older planet. Everything kind of formed at the same time. Everything formed at the formation of our solar system. And so when we are looking at everything, it's all about the same age. Yeah. And that is our solar system. It is star is our star, the planets, ice, rock, asteroids, and comets, and the dwarf planets. It's not just the 8 planets.
Yeah, so I just wanted to remind everybody, this is the portion of class where you get to ask your questions. So if you're a junior out there in our Zoom meeting listening in, you can, of course, write your questions in our Q&A box. That's that little button. If you scroll your mouse down to the bottom of your Zoom screen, it says Q&A. You can also chat with us too, and I know a bunch of you already found that too. So feel free to ask questions in there as well. And we'll be happy to take as many questions as you guys have. So we have a first question from Chantel, wondering, how long have you studied all this stuff?
Me?
Yeah.
Wow. So I actually went to school for physics. I got my bachelor's of science in physics actually just in December. So I just graduated from school. But I am I'm applying for another path. I am applying to get my master's and or doctorate in cosmology. So hopefully I'll be learning all of this for another 4 years, but I did study all of this for about 4 years. but I've had this interest actually since I was your age. I fell in love with the stars when I was a brownie, and I didn't think anything of it. I didn't think it was something that I could pursue. I thought I had to do something like I would have to do like an office job, or maybe I would be like a firefighter, or a police officer, or maybe go into business or music. But I didn't think that I could study the stars. And so when I got to high school, I was like, oh, physics, whatever. But then I took the class and I was like, whoa, this is actually really interesting. And oh my God, it's space. Oh my God, black holes. Oh my God, binary systems. This is really cool. And all this stuff started happening in the scientific community. And so I really took notice then, and I did a lot of studying on my own. And so I've really been learning all of this since I was a sophomore in high school, but I have my formal training in school for about 4 years.
So guys, if you want to ask your questions, now is definitely the time. Feel free to chat with us in the chat window or to put them in the Q&A. And we're happy to answer them while we have Hannah here live. And of course, if you have questions after class and you just think of them then, that's not a problem either. You can email Hannah or myself. Hannah is at hbuckner@fairbanksmuseum.org. I'm at dbush@fairbanksmuseum.org also. So feel free to email us your questions anytime.
Wow. So I think I'm going to pronounce your name right, Freya. Very pretty name. So it is not that hard to pursue science. Don't let anybody convince you otherwise. I think it's only as hard as you let it be. There are obstacles that I've had to overcome, where sometimes someone said that I couldn't study something because I was a woman, or because that wasn't where my inclination was, or maybe it wasn't right for me because I was doing a little bit difficult. I was struggling a little bit, but I knew this is what I wanted to do. And I've had a heart for science, and it's my passion. And so I didn't let it be that hard. I actually excelled in school. For a while, I wanted to study genetics. And so I was very interested in biology and chemistry. So I would just say, whatever your passion is, even if it's science or not science, don't let somebody tell you that it's too hard to do, because then that's just an obstacle that you're creating for yourself. You can go as far as you want to go. You are your only limit. And so science, it can be hard, and it is a lot of learning, but I think it's worth it in the end. And you know, if you study, if you learn, if you pay attention, if you ask questions, anybody would be so happy to help you learn, especially if you show that it's something that you are actually interested in and want to engage in, want to have someone to foster mentorship with you. They would be so happy to help you with that. And if they don't, well, find someone else, because they are not someone that you want to work with. And if someone gives you trouble and you can't find them, you come to me and I will give you help. It's only as hard as you let it be. And then for Miriam, who says, am I planning to work for NASA? That is my hope. I would love to work for NASA. NASA is the dream goal. I personally don't want to be an astronaut. I mean, I would love to go to space, but just medically, I don't think that's really in the cards for me. But I would love to work for NASA. I would love to work on research with them and do so many cool things, or work at a telescope that works with them. Oh, that would be cool. Ashley, I love your question. Dark matter and dark energy are matter and energy that we don't know anything about. It's matter, they are matter and energy that we cannot detect, that we cannot see, but we know that it's there because the way that the universe is working, give me 1 second, Drew. The way that everything is working, we know that there's some other mass and force that is there. So yeah, it's there. We don't know what it is. We can't detect it.
Oh, so we have 2 more questions in the Q&A, but I wanted to make sure we asked the one that was in our chat also, or answered the one that's in our chat also. So how do scientists study the farthest away planets?
I'm sorry, can you repeat that? You got cut off.
Oh, how do scientists study the furthest away planets? What methods do they use? How do they do it?
So I don't know if you mean in our solar system or if you just mean in general. In our solar system, we use quite a number of things regarding technology, and I almost don't want to answer your question because we are going to talk about that in another class. It'll be in our last class, so that's exciting. But I will say we use satellites, we use telescopes, we use some cameras that can work in space, and some various physics things called adaptive optics. And we can use that to study our solar system. If we're looking at exoplanets, there are some other things that we can do. But I encourage you actually to reach out to me through my email, and we can discuss that more over email because it's too long to talk about. There's a lot of stuff that we use. So to Haley, I actually am a scientist. Well, I consider myself a scientist. I graduated my degree in physics, and I do science education, and so I think of myself as a scientist. I hope to be formally labeled a cosmologist at some point. I hope to do that. And then Freya, the science and physics that you do, what is it called? And are there more than one type of science? So, ooh, wow, okay. Yes. Let me just pull it up one more time. Okay, so the science and physics that I do is okay. So what I study is called cosmology, or astrophysics. I kind of dabble in both fields. So cosmology studies the cosmos and the universe and kind of deep space bodies, celestial objects like white dwarfs, red giants, supernovas, pulsars, other stars like that, and dark matter, dark energy, black holes, kind of that. But astrophysics kind of takes astronomy and puts physics into it, and studies theoretical and observational things about them. So there are kind of aspects about it. Well, I'm not sure if you mean fields of science. So there are many fields of science. There's the general, which is chemistry, biology, physics, psychology is a social science, social work is a social science. There's geology, then there's like virology. There's just like subsections. There are so many sections of science that I probably could go on for a whole day just listing them, and then listing their subsections of the subsection. There's a lot. There's so much science. Science runs the world, literally. Yeah. I actually encourage you to kind of, with a parent, kind of go through Wikipedia and just look through all the different science topics. They're really cool, really interesting to look up. If you're like me and you like to just read all day, that's really cool because you can learn a lot just by browsing that or going through NASA or looking up at the different association websites that have, like, for American Chemical Society, American Biological Society, American Physical Society, wait, no, the American Society, no, yeah, American Physical Society, which I'm a part of, in their institute. There's a lot, so definitely look that up.
Yeah, so unless we get any other questions here, I think we might end class for the day. So I'll give folks a few seconds to type in if you have any last questions that Hannah can answer for you. I wanted to remind everybody that we're, of course, very sorry about the technical issues we had with our class today, but we will be back for the next 3 weeks so that you can finish up your badges. And we'll be at the same time on Fridays, but we'll have all of that sorted out so that it's all on Facebook for the Girl Scouts of the Green and White Mountains. And you know, if anybody missed today's class or missed the beginning of it, we'll be posting the video shortly after class today as well. So make sure you check back on the Girl Scout website, Facebook page, I should say.
And if you are interested in other classes, the museum that we work at, the Fairbanks Museum and Planetarium, well, no, Drew works there, I serve there through AmeriCorps. We offer free classes, and all of my astronomy classes are up there, so feel free to find them in the archived classes under the oh my gosh, virtual learning. I'm tired. And yeah, feel free. And Nicole, please send me an email because I cannot respond right now.
So maybe we can take Nicole's last question if you want.
Okay. Well, I haven't been working with planets. I've done research on moons. I did research with Jupiter's moons, so 3 of them. So there's 4 moons called the Galilean Moons, which were discovered by Galileo. Well, Galileo Galilei, back in the 1700s, I think, or 1600s. And so his 4 moons are Io, Callisto, Ganymede, and Europa, completely out of order. And so I did research with Io, Europa, and Ganymede, kind of studying their behavior. But mostly what I've done so far is astronomical imaging, but I want to look more about kind of just like the lives of stars. So yeah, that's been about 2-3 years.
Cool. Well, seeing that I think we've answered all the questions today, and I just wanted to thank everybody for sticking with us and joining us in our Zoom meeting. And yes, this is the first step for that badge that you're all working on as juniors. So we'll be back next Friday. Of course, if you want to catch up on anything you missed or to rewatch this class, it'll be on the Facebook page for the Girl Scouts of the Green and White Mountains, the video that is. And if you're interested in any of our other offerings in astronomy and in other subjects, you can visit fairbanksmuseum.org. We're excited to have you all here with us today and to be partnering with the Girl Scouts of the Green and White Mountains on these classes just for your badges. So thank you, everybody. And oh, I should mention that there are handouts that go with today's classes for you to do at home. So make sure you check in on that Facebook page again, the Girl Scouts of the Green and White Mountains Facebook page. So thank you, everybody, for joining us. And I hope you have a wonderful evening and weekend. And we look forward to seeing you next Friday. And thank you to Hannah, of course.
And I just want to start. Yeah, thank you. I just want to say also, the activity is also part of earning your badge. So please look through the handouts. You will need them.
Great. Well, thank you, everyone, and have a great evening.
Thank you, Drew.